Hello everyone, and welcome to this new bonus case study on Telecom customers churn prediction. In this hands-on project, we are going to train a machine learning classifier model, and the objective is to predict the churn rate of telecommunication customers. In the telecom service industry, keeping or retaining a customer is an important metric, since the cost of retaining an existing customer is far less compared to the attempt to acquire a new customer. And that's why what we're going to do in this project is that we're going to consume a lot of data about our customers, such as their tenure rate, like how long they have been with the given company, the number of services that the customer has subscribed to, the payment method, for example, the number of minutes that have been consumed, if they have maybe voicemail or not, how many minutes are they using per day or not, per day. And essentially we're going to use all that data to train a machine learning classifier model that could predict for us whether that customer will stay or will leave. So by knowing that, we will be able to understand the important features that we can essentially improve or maybe focus on to keep customers onwards, just to avoid customer churn. Okay? All right, so what we're going to do in this project is that we're going to train a machine learning classifier model, and we are going to use DataRobot to do that trick for us. If you guys wanted to learn more about DataRobot, I've included an extensive case study, detailed case study in the course, but this is a bonus additional case study. So I'm going to show you guys how to do all the different steps, but you know, when you build, train, test, and deploy machine learning models with DataRobot. But if you guys wanted to take it a step further and maybe understand, let's say, how to sign up, for example, for DataRobot, you guys need to check out the course lectures. So let's go ahead and get started with DataRobot training. So what we have in here is that we have the DataRobot landing page, and essentially you can either use DataRobot to do data preparation, or you can do machine learning development, or you can do machine learning operations. And in this project we are going to focus on the machine learning development. And what you guys see here is it's telling you that you can use AutoML, visual AI, and more to build machine learning models in a couple of minutes. And that's right, you don't need to do any coding at all. All what you need to do is to have access to that data, understand just a couple of points about your data, such as what is the input, what are the outputs, and is it classification type problems or regression type problems, to solve that for you. And all what you need is to upload the data to DataRobot, and then DataRobot will gonna do all the trick for you. Instead of training one model, DataRobot will actually gonna train many models, like at least 10 models, and then is going to rank them on a leaderboard, and then the best model will be ready for you for deployment. So again, it can't get any easier than this, basically. So you're gonna pick up the best model out of all of these, and you will be able to deploy the model and create an application as well with just a couple of clicks. So let me show you how we can do that. So first of all, let me show you the actual data set that we'll be working with. So here is a data set. It's called Telecom churn data. And there are a lot of features in here that we try to essentially feed to the model and predict if these features affect the customer churn or not. So basically all the data that we have in here, all of these will gonna be input to the model. This one, which is a class, that will be the output from the model. And of course, what you guys can see here is that this type of problem is considered or classified as a classification type problem, because the class here is either 0 or 1. So either the customer stayed or the customer left, basically. And these are a ton of features. So for example, we have the number of voicemail messages that the customer use. We have the voicemail plan, if the customer has a voicemail or not. Total day calls, for example. Total day charge. How many minutes they are using in the evening. how many days, how many night minutes they are using, the total night calls, total night charge. And we're going to consume all that data and essentially try to predict if the customer will stay or not. Okay? All right. So let's go back to DataRobot. And the first step to train a machine learning model in DataRobot is to basically go to the machine learning development tile. Please go ahead and click on it. And then you need to go ahead and create new project. And all what you need to do is that you need to go ahead and just drag and drop your Excel sheet in here. And what you guys notice as well is on the bottom here, there are a ton of available common use cases for you. So if you guys wanted to maybe develop a machine learning model that does hospital, let me go back, hospital readmission, for example, prediction, or if you wanted to detect plant disease, for example, or if you wanted to perform predictive maintenance or understand the risk of loan default. Again, tons of applications available for you, and you can go ahead with these use cases and learn a lot. Okay. So what I'm going to do is I'm going to go ahead and drag and drop the Excel sheet in here. So here I have my Excel sheet. I'm just going to drag and drop the Excel sheet to the DataRobot upload. And what you guys can see here is simply the data is being uploaded right now, and DataRobot is essentially doing a quick raw data read, and then it's going to perform exploratory data analysis. So it's going to visualize the data, explore the correlations and associations between features. And please note that here we are in the data tab. Once the model is trained, and I'm going to show you guys how to train the model, all the models will appear here under the models tab. Okay. And of course, if you wanted to deploy the model and create an application, all the applications will be under the application tab. Okay, so here we go. So now the data has been uploaded. And what you guys see here is here I have all the different features that I showed you guys in the Excel sheet. So if you guys go to the class, which is my output or target column, here we go. So these are the customers who stayed. So all of them are classified as 0. And these are the customers who churned, basically who left, essentially. So here I have around 707 customers who left our company. And here we have around 4,200 samples or customers who stayed. Okay, and if you guys click on any of these features, you should be able to see the total day minutes, for example. So this is a nice normal distribution. If you guys wanted to explore maybe the total day calls, for instance, these are the total day calls, and you should be able to see as well here. If you see here on the top, you should be able to see a box plot that can show you the 25 percentile, 75 percentile, 50th percentile, and the overall distribution, essentially that matches with the histogram that we got in here as well. And if you guys scroll down, maybe we can get total international charge. Here's again the data set. And please note as well that kind of DataRobot, and that's what I really like about it, is that it can give you a lot of information about your features in just one place. So basically what we see here is that we have the mean value of the total international charge, so around $2.7. We have the standard deviation, which is the dispersion away from the mean. So here it stands at 0.75. We have the median at 2.78. We have the minimum at 0 and the maximum value at 5.4. Okay. All right. So the next important step that we need to perform is that we need to select our target. We need to select the output. And please note that all what you need to do to start the training is to just go here and click start, right? That's all what you need to do. The only problem is, well, this start is not activated unless you go ahead and select your target. You need to, DataRobot cannot predict what are you trying to predict, basically. So you need to specify what's the input, what's the output, and DataRobot will take it from there, okay? So what you guys see here, it's telling you, okay, enter your target. That's one way of selecting the target. Or you can go ahead here and say select target, or you can go down here to the features and say use as target. So the class, you can go ahead and say, well, please use that as target. And once you do that, it will show here as green. You don't need to feed the target here anymore. And the start training has been activated, okay? And that's great. Another point as well is that what you guys see here is the class or the distribution. So here I have the distribution is 0, distribution 1, and of course it looks like we have an unbalanced data set in which the number of customers who stayed were a lot more compared to the customers who churned. Another important point to show you guys is if you go to the data quality assessment tab, and if you click on it, it can show you that there have been a couple of outliers that have been detected in a couple of features. So basically, if you have any issues with the data or any problems, again, DataRobot can take care of that, and can just flag it basically, can show you here that, okay, well, in the total daily calls, there has been a problem here. So if you click on it, what you guys see here is, this is the normal data, right? Without the outliers. So if you wanted to show the outliers, you can go ahead here and say show outliers, and it's calculating all the outliers locations. And what you guys notice is after the calculation is performed, you guys will see that essentially you would see like points that are at crazy extremes, okay? And these are what we call it outliers, and just DataRobot is flagging it as a problematic. So basically here we have an outlier at 0, okay? So that's like, you know, like way far ahead from the average or the mean values, okay? All right, because the issues here are not, I would say, severe, so we're just gonna skip them for now. We're not gonna be doing any data pre-processing. And all what you guys need to do is to please go ahead and just click on start, and that's it. That will take care of everything for you. So if you guys click on start, what you guys can see is now the model, now DataRobot is basically training for you multiple models on the right hand side here. First, it is setting the target feature. It's creating what we call it the holdout partitions and cross-validation partitions. If you guys wanted to read a little bit more about it, you can go ahead and check the course package. I've included a ton of information on that. But the overall idea is that we take the training data, we take the whole data, and then we split the data into training, testing, and cross-validation, okay? We train the model with the training data. We use the cross-validation data set to make sure that the model is not overfitting the training data while the model is trained. And then we have the last subset of the data, and that's what we call it the testing data set. This data set has never been seen by the model during training, and it's kept separate. It's kept away, basically, okay? And that's how we truly assess the performance of the model using an unbiased data set or unbiased assessment. And what you guys see here as well is the DataRobot is training many models for you. So there are Keras-Slim residual neural network is being trained. We have extreme gradient boosted trees. We have elastic net classifier models. And if you scroll down, we have a ton of other models as well that is being trained. And if you guys go under models, you guys will see here that these are all the models that is being trained or has been trained already. And it's showing you, of course, the performance of the model. Here it's showing in progress. Here is the performance of the model. And what we're going to do is we're going to leave it to run maybe for, I would say, 10 or 15 minutes. And again, DataRobot will train all these different models for me, and all of them will appear under the leaderboard here. So under the leaderboard, you should be able to see all the different models, and the best one will be ranked here on top. And that will be the best model that we can essentially use for deployment. So what I'm going to do is I'm going to pause the video, and then I'm going to be back once the training is complete. We'll see you guys shortly. All right, so now I'm back, and what you guys notice here is I have our leaderboard, and here I have all the different models that DataRobot has trained, okay? And so basically what you guys see is that there are tons of models that have been trained. If you guys see here, there are 20 models, and actually it's still training and performing hyperparameters optimization as well in the background. But overall, what we can notice here is that the rule fit classifier model actually worked great, and that was the best one out of all. What you guys notice as well is that here there is what we call it the model ID. So the model ID here is listed as 51. And you guys will notice that there are tons of other IDs as well. There is model 49, there is model 18, and so on. Another point as well to illustrate is that these models are actually programmed in different programming languages. which is super powerful. Again, I started in this field around, let's say, 10 or 11 years ago in the field of AI and machine learning. And before, you actually had to go and code these algorithms by hand. So I had to go and write all the scripts, for, let's say, for random forest classifier models. And you have to go and learn Python, for example, or maybe you have to go and learn MATLAB or learn R and so on. So what you guys notice here is, well, all DataRobot actually has all these models behind the scenes. They are optimized for computational efficiency. And what you guys notice as well is that they are written in different programming languages, which is pretty incredible. So for example, the gradient boosted trees classifier is written in R programming language. The random forest classifier is written in Python. If you guys scroll down, you should be able to see as well here I have the neural network. So here we are essentially using deep learning to perform regression tasks. And what you guys notice is that this is essentially a Keras model. So Keras and TensorFlow, these are tools that could be used to build, train, test, and deploy neural network models at scale. And essentially Keras is a high-level API that sits on top of TensorFlow, which is Google's framework to train machine learning models and neural networks specifically. And again, to code all of that, you need to know how Keras works, how TensorFlow works. But now you don't need to worry about any of that. Basically, just DataRobot will gonna go and call all these models for you. And overall, if you guys click on the rule fit classifier, here we go. What you guys see here is pretty powerful. First of all, what you guys see is this is simply the model blueprint. So here I have the data. Here I have numeric variables. And if you click on it, it can show you what that block is doing. Here I have the missing value imputer. So basically here this block simply imputes missing values on numeric data. And if you guys wanted to read more about the documentation, you can simply go ahead and just open the documentation and it can show you what is this function is all about, and of course showing you how it's doing the imputation and so on. Next, here we feed that data after performing the feature engineering, and then we feed that to a rule fit classifier to make the predictions. If you guys wanted to learn more about the algorithm that is running in the background, again, if you click on it, you should be able to see all the different hyperparameters that have been used in the model. And if you click on the documentation, you should be able to see all the different documentation for the rule fit classifier and what these parameters actually mean, which is again super powerful. Okay, the next point is if you click on evaluate, now I need to know how that model is actually performing. So what you guys see here I have my average target values, and it looks like my model is doing pretty good. So these are the different predictions. The blue here crosses, these are predictions, and the orange one is the actual values. And it looks like the actual values and the predictions match pretty well. If you guys check out the ROC curve, or receiver operating characteristic curve, please know that we in the course we cover that in great details, how it works, what it does, and so on. I just want to give you from a very high level what is happening here. So on the x-axis, I have the false positive rate, which is essentially what we call the fallout. And on the y-axis, I have the true positive rate, or what we call it the sensitivity or recall. And if you have a model that is at a perfect 45-degree angle here, that means this classifier is useless because it's making a lot of mistakes and is doing as well good stuff too, but that at a 50% chance, right? And that's what we call it a random classifier. And we hate that. We don't like those, of course. So what we want is that we want a ROC curve or receiver operating characteristic curve that is skewed toward the top left corner. So a curve like that looks great. Why? Because that means the model is doing more of the positive stuff, of the good stuff, is making good predictions compared to messing up, compared to making false predictions. And this curve actually is pretty good, and you guys will see that what we do as well is after we plot the ROC curve, we obtain what we call it the AUC, or the area under the curve. So as the area under the curve becomes more than 0.5, that's a good thing. As long as I'm on top of this line, I'm doing great. So if it's somewhere here, and the more skewed toward the top left corner, the better. Okay, so what you guys see here is, well, the model first performed on the F1 score 0.83. An F1 score is simply the harmonic mean between the precision and recall. What you guys see here is the accuracy is set at around 95%, which is pretty great. Also, I have here the true positive rate at 0.75. I have the true negative rate at 0.99, and precision as well is set at 0.93, which is quite high. And that's kind of give you an overall idea of the performance of the model. Another key point to show you guys is what we call the confusion matrix. And this is just one matrix that can show you how the model is performing. How many true positives, how many false positives, true negatives and false negatives. And it looks like the model actually did pretty good. So these are the good stuff, meaning these are the true negatives and the true positives. And these are the number of samples that the model has messed up. So the model has messed up 35 samples here and 7 samples here. And these are the false negatives and false positives. Okay, so this is just from a very high level how the model is performing. What I'm going to do is I'm going to show you guys in the next lecture how to take that model and simply deploy it and make predictions as well. So please stay tuned. Best of luck, and I'll see you guys in the next lecture.